your head around, generally speaking, what it means to be correlated, what it means for there to be an association, let's talk now about the actual correlation coefficient. So the correlation coefficient is a number that's going to represent both the strength of the correlation and also the sign, whether it's a positive correlation or a negative correlation. And the correlation coefficient is both a statistical test statistic, like the T statistic was back a couple of weeks ago, but it's also a measure of effect size. So it's one of these nifty numbers that does both of those two things. It's both your test statistic and it's also a representation of a standardized effect size. So it's going to give us information about how strong the relationship is. And the Pearson's correlation coefficient, it ranges from -1 to +1, with a correlation of 0 meaning no relationship, no correlation. So the closer to 0 it is, the weaker the correlation. If it is absolutely 0, it means there's no relationship whatsoever. The closer to either +1 or -1, it doesn't matter, the stronger the relationship is. And the positive numbers represent a positive relationship, positive correlation, whereas the negative numbers represent a negative correlation, a negative relationship. But the closer it is, the closer the number is to either 1 or -1, the stronger the relationship. And we have a couple of cutoffs, a couple of kind of rules of thumb for what's considered a weak versus a moderate versus a strong relationship. And this is the same principle as when we were talking about Cohen's d effect sizes a few weeks ago, where we were talking about how you could use the actual size of the number to say, is it a big difference between the groups? Is it a small difference between the groups? It's the same principle here. So the actual size of the correlation coefficient itself tells you how strong the relationship is. So a correlation, and we're talking here in absolute values. So all of these rules of thumb are in absolute values. It doesn't matter if it's positive or negative, the absolute value is the same. The actual value itself is the same representation of the strength of the relationship. So a correlation from 0 to 0.1 means a very weak to no relationship. A correlation from 0.1 to 0.3 represents a weak relationship. A correlation from 0.3 to 0.5 is a moderate relationship. And anything above 0.5 is generally considered a strong relationship. But keep in mind that these are absolutely just rules of thumb, and they're where the actual correlation sits within those cutoffs is also meaningful. So a correlation of 0.49 is not meaningfully different to a correlation of 0.51, even though one is technically in the moderate category and the other one is technically in the strong category. But the actual cutoff points there, the actual delineation between the categories is really just lines in the sand. So it's all about how big the number is. The closer to 1 it is, the stronger the effect. The closer to 0 it is, the weaker the effect. And what the correlation coefficient is actually representing, what the actual number itself is actually representing, is how much variability there is in scores on your dependent variable or on your outcome variable for any particular given value of your independent variable. Or put that another way, the strength of the correlation is representing how much variability, how much kind of difference in scores, how big a spread of scores you're seeing in your y-axis variable for any particular value of your x-axis variable. And we did that in demonstration back on slide 6 a couple of slides ago. So that's what the actual correlation coefficient is showing you. It's how much variability there is around a line of best fit, which is a concept we'll come to in a few slides' time. And that's Ryan Gosling, just because he is great and we have a lot of stats memes with him on the internet, and that's just a very enjoyable element of our lectures here. So something a little bit more useful, the correlation coefficient kind of depiction down the bottom there is showing you that correlations closer to 0 are representing weak relationships, correlations closer to 1 are representing stronger relationships. And again, it doesn't matter whether it's positive or negative in terms of how strong the relationship is, it's about the absolute value. All right, this slide's representing just a couple of different examples, and we've got a few different examples of different strengths of correlations over a few slides. And this is really showing us that the correlation, the actual size of the correlation coefficient, the strength of the correlation, it's not about how steep the slope is. It's not about how vertical versus how horizontal that actual line is. It's about how tightly clustered around the line our points are versus how spread around the line the points are, how much variability around the line the points are. So the graph on the left-hand side and the graph on the right-hand side represent perfect correlations, one-to-one correlations. And that has got nothing to do with the steepness of the line. It's the fact that all of those data points, all of those individual circles, lie perfectly on that straight line that's been drawn through them. And that straight line is also represented, or also called, the line of best fit. It's also called a regression line. So the fact that these are perfect correlations is represented by the fact that there is no variability around the regression line, around the line of best fit, that all of our points lie absolutely perfectly on that line. And in contrast, you can see the graph in the middle, which is representing no correlation whatsoever. And here there is a heap of variability around that line of best fit, that horizontal line there, in that there's no consistent positive trend, negative trend, there's no consistent trend going on there. It's just a random scattering of points. This is also another demonstration of kind of the same concept. So on the left-hand side and the right-hand side, we have two different strengths of correlations. On the left-hand side, we have a high, a strong correlation. On the right-hand side, it's a low correlation. And this has nothing to do with the actual slope, the actual steepness of that line, or of the actual pattern between the representation of the association between the IV and the DV. It's all about how tightly clustered together the individual data points are, or how much variability in scores there are for any individual value of the variable that's on your x-axis. So it's about how tightly clustered together your points are compared to how spread apart your points are around that imaginary straight line that goes through the bulk of your points, called the line of best fit. So if I haven't made that point clearly enough so far, don't confuse the steepness of the slope with how tightly clustered the points are with the correlation. A perfect correlation means the data points are making a straight line. They fall perfectly on that straight line. It doesn't matter how steep the line is, as long as there's some positive or negative trend, straight line trend. And weaker correlations mean the data points are more dispersed, they're more variable, they're more scattered around the graph. Still doesn't matter how steep the line is. And no correlation at all means that there's no linear pattern to the data points. And this is a really nice demonstration, I think, of just the variety of different kinds of correlations that you can see. If you have a look at the middle row, all of these are perfect correlations, except for the middle one, which are represented by the fact that all of the data points form a very perfect straight line, regardless of how steep versus how flat that line is. Whereas on the top there, you can see that all of the three graphs on the left-hand side and the three graphs on the right-hand side of that very first row, they all have the same steepness of slope, but the only thing that's varying there is the dispersion or the spread of points around that straight line. And the point that we're making with the bottom row of points here comes back to this aspect of linearity. The fact that a correlation is testing to see how strong a linear or a straight line association is. And what that means is that any of these individual patterns that you see, these very pretty patterns in the bottom row here, would all be represented by correlations of 0 because there's no straight line trend. And I'll demonstrate that a bit more when we actually have a look at some of the scatter plots themselves. A little bit of an interlude, if you need a bit of a break at this moment, is that this is a really cool thing. Well, cool to me, you'll probably just laugh at that, which is fair enough, that you can spend a whole lot of time doing and wasting if you just want to have a play around guessing a bunch of correlations. So what this website does is show you a bunch of different scatter plots, and you have to guess what the correlation coefficient would be. So try it out yourself and see how good you are at guessing correlations.